Hi, everyone. Welcome back to Organic Chemistry in 5 minutes or less. Today, we'll be talking about radical chain reactions, this time the chlorination of alkanes. Last time we covered the bromination of alkanes, and today I hope to introduce you to the mechanism and the origin of the selectivity for chlorination versus bromination. First, a chlorination reaction is the substitution of a hydrogen in an alkane with a chlorine atom. This occurs by treating the alkane with diatomic chlorine in the presence of light or heat, and the selectivity changes based on the type of diatomic that is used. Suppose you have the reaction of a propane in the presence of chlorine and light. Here, you form the 2-chloropropane 60% of the time, and you form the 1-chloropropane 40% of the time. Okay, so the mechanism starts with initiation. The chlorine molecule is homolytically cleaved. Remember, these Fishhook arrows mean that one electron is moving away from that sigma bond into the 2 chlorine atoms. Okay, you have a propagation step involving this propane plus the radical. This forms a secondary radical plus hydrogen chloride. The secondary radical in a termination step reacts with another chlorine radical to form the product 2-chloropropane. The reason that this reaction is favored at the 2 position instead of the 1 position is that in the dominant pathway, the one leading to 60% yield, you form a secondary radical, whereas the analogous reaction for the disfavored product involves the abstraction at the 1 position. So the initiation is the same, but now you use the chlorine radical to abstract at the 1 position, which leads to the primary radical plus HCl. So if you compare these 2 energies, you'll recall that a primary radical is higher in energy than a secondary radical. This is generally the case unless resonance or inductive effects play a role. Here, there are not any inductive or resonance effects, so we can just trust this general trend. And this high energy intermediate also corresponds to a higher lying transition state, which slows down the reaction for the primary pathway. Remember, the higher the activation energy, the lower the reaction rate. So the higher energy reaction pathway involving a primary radical leads to a slower reaction for the primary chloropropane, slower reaction for the primary chloropropane, and the 2-chloropropane is faster because the energy of the intermediate and transition state are lower in energy, which make that reaction faster. So if you're looking for questions to ask at office hour 1, you could ask, can you describe the origin of the higher energy of a primary radical versus that of a secondary radical? Why are reactions with higher barriers slower than those with lower barriers? That's been Organic Chemistry in 5 minutes or less. Thanks very much for tuning in.